In this problem, we have 3 points located at the vertices of an equilateral triangle with side length a. They all start moving simultaneously with constant velocity v, with the first point heading continually for the second for the third, and the third for the first. Our goal is to determine how soon these points will converge. Let's start by setting up and visualizing this problem. Here we have an equilateral triangle with points P1, P2, and P3 at its vertices, each side having length a. The points will move with constant speed v, with point P1 always heading directly toward point P2 toward point P3, and point P3 toward point P1. Now, let's show the velocity vectors. Each point moves with a velocity of magnitude v, directly toward the next point in sequence. Notice that the direction of each point's velocity is not along the side of the triangle, but directly toward the next point. This is a key insight for solving the problem. Let's see what happens as the points begin to move. As the points follow each other, the triangle begins to shrink while maintaining its equilateral shape. This symmetry is important to our solution. To determine when the points converge, we need to understand how the side length changes over time. Let's focus on one side of the triangle, say, the side connecting points P1 and P2. The angle between the velocity vector of point P1 and this side is 60 degrees. This is because in an equilateral triangle, each interior angle is 60 degrees, and the velocity of point P1 is directed toward point P2. Now, we need to find the component of the velocity that contributes to reducing the side length. The component of point P1's velocity along the direction of the side is v times cosine 60 degrees, which equals v times 1/2, or v over 2. Similarly, the component of P2's velocity toward P1 is also v over 2. Together, these cause the side length to decrease at a rate of v, since both points are moving toward each other. Now we can determine the time until the points converge. The side length decreases at a constant rate of v. Since we need to find how long it takes for the side length to reduce from a to 0, we can calculate the time as distance divided by rate, which gives us over v. Because the triangle maintains its equilateral shape throughout the motion. When one side reaches 0 length, all 3 sides reach 0 simultaneously, meaning all 3 points converge at exactly the same time. Therefore, the time until convergence is simply a divided by v. Let's recap the solution. We started with 3 points at the vertices of an equilateral triangle with sides of length a. Each point moved at speed v toward the next point. We found that the component of each point's velocity that contributed to reducing the side length was v over 2, with 2 points moving toward each other. Each side decreased at a rate of v. Since the distance to be covered was a, the time until convergence is simply a divided by v.